Welcome to Knowledge Gainer 1 channel. Let us continue our permutations and combinations topic. Note point, there are m boys and n girls. The number of ways in which they can be arranged so that all the girls do not sit together is m plus n factorial minus m plus 1 factorial into n factorial ways. The question is, there are 5 boys, 3 girls. In how many ways can they be seated in a row such that all the girls do not sit together? Here m is equal to 5 and n is equal to 3. Now substituting the values in the above formula, m plus n is 8 factorial minus m plus 1 is 6 factorial into n factorial is 3 factorial ways. 8 factorial value is 40,320 minus 6 factorial into 3 factorial is 4,320. On subtracting this, we get 36,000. In 36,000 ways, these girls and boys can be seated so that 3 girls do not sit together. 12th one, the number of ways in which m boys, m girls can be seated in a row so that their alternate is 2 into m factorial ways. In the first case, if boy is placed first, next girl should be placed, then boy and girl. This is arranged in m factorial ways. In the second case, first girl is seated, then boy, then girl and then boy. This is also arranged in m factorial ways, 2 into m factorial ways. And in the same problem, if the number of boys is m and girls number is m minus 1, the number of ways they should be placed in alternate way is m factorial into m minus 1 factorial. Because if we place a boy first, then girl, then boy, then girl and then boy. If we place the girl first, next should be boy, next should be girl, next should be boy. Here also we get the boy if we place the girl first. So this is not correct. 13th one, the number of ways in which m persons of a particular group, m persons of other group can be seated along a circle so that their alternate is m factorial into m minus 1 factorial ways. 14th one, a round table conference is to be held between n delegates. The number of ways in which they can be seated so that m particular delegates always sit together is n minus m factorial into m factorial ways. 15th one, find the number of ways in which 6 different beads can be arranged to form a necklace. The formula we use here is number of beads minus 1 factorial by 2. Here the number of beads is 6 minus 1 factorial by 2, that is 5 factorial by 2. 5 factorial value is 120 by 2. So the number of ways is 60 ways. 16th question. How many words can be formed with the letters of the word Pataliputra without changing the relevant order of the vowels and the consonants? There are total of 11 letters in the word Pataliputra, of which 6 are consonants and 5 are vowels. Here the relevant order of the consonants and the vowels should not be changed. So the consonants occupy the space of the consonants only and vowels occupy the space of vowels only. Here the 6 consonants are arranged in 6 factorial ways. By there are 2 p's, so by 2 factorial, and there are 2 t's by 2 factorial. Here 5 vowels are arranged in 5 factorial ways and there are 3 a's, so by 3 factorial. So the required number of words is 6 factorial by 2 factorial into 2 factorial into 5 factorial by 3 factorial. From this we get 3600 words can be formed. 17th question. In how many ways 8 Indians, 4 Americans, 4 Englishmen can be seated in a row so that all the persons of the same nationality sit together? There are 8 Indians, 4 Americans and 4 Englishmen. But these persons of same nationality should sit together. So consider this as 1 and this as 1. So these 3 can be seated in 3 factorial ways. And the 8 Indians can be seated among themselves in 8 factorial ways, 4 Americans can be seated among themselves in 4 factorial ways, and the 4 Englishmen can be seated among themselves in 4 factorial ways. So this is the required answer. 18th question. 4 boys, 2 girls are to be seated in a row in such a way that 2 girls are always together. In how many different ways they can be seated? There are 4 boys and 2 girls, but these 2 girls should be seated together, so consider this as 1. So there are 5 in total. So these 5 persons can be arranged in 5 factorial ways and these 2 girls should be arranged themselves in 2 factorial ways, that is 120 into 2. So 240 ways. Let us see some note points. The number of permutations of n different things taken r at a time when particular thing is to be included always is n minus 1 p r minus 1. R at a time when particular thing is never included is n minus 1 p r. Taken all together when m specified things always come together is m factorial into n minus m plus 1 factorial. Taken all together when m specified things never come together is n factorial minus m factorial into n minus m plus 1 factorial. 19th question. Find the number of ways using all the letters of the word matrix so that all the consonants come together. there are 4 consonants and 12 vowels. Consider this as 1. So total 3. These 3 can be arranged in 3 factorial ways, and the 4 consonants can be arranged themselves in 4 factorial ways. So 3 factorial into 4 factorial is 6 into 24, that is 144 ways. By using the formula, it is m factorial into n minus m plus 1 factorial. That is m is 4 factorial into 6 minus 4 plus 1 factorial. 4 factorial into 3 factorial is 144. Question number 20. Find the number of ways of arranging the letters of the word associations in which 2 A's do not come together. There are total 12 letters. We should not consider A's here. So there are 10 letters. First we should arrange these 10 letters in 10 factorial ways by the repeated 3 A's in 3 factorial ways, 2 O's in 2 factorial ways, and 2 I's in 2 factorial ways. After placing all these 10 alphabets, there are 11 places, so that we can place the 2 A's in 11 P2 ways. The required answer is 10 factorial by 3 factorial into 2 factorial into 2 factorial into 11 P2 by 2 factorial, because there are 2 A's. Thanks for watching. Please like, share and subscribe to Knowledge Gainer 1M channel, and also press bell icon to get notified.